this is a super common question on the AP test, all right? And I want to talk about the difference between finding absolute maxes and finding local maxes, all right? But this will be a calculator question. I'm going to show you how to handle it, and just the process is very specific to the AP test, okay? So, given a derivative, which they might call the rate of something, they might not say it's a derivative, right? But I'm telling you right now, this is f prime of x, all right? We can tell how fast f is changing. That's what that does for us, right? And since we have a calculator, we're going to put this into our calculator. And we're going to graph it on the window that they're asking about, which is from 0 to 7. So, you're going to grab your calculator. You're going to go into y equals. You're going to make sure you're in radians. You're going to type in, not that, e to the x, sine of x. Okay?
Yes. Where's it
It's ln, second ln is e to the x, okay? Am I good? Now, we're going to graph it to see, and this is going to tell us some stuff about f. All right, that's the whole point of these questions. So before I graph, though, I'm going to go to my window. I'm going to make sure my x is going from 0 to 7, because that's what the question asked about. I'm going to count by ones, because 0 to 7, counting by 1 sounds good. And before I pick my y values, let's think about this. We're going to have e to a power here, right? So e to the 7th is a big number. Right? Like 2 to the 7th is like 256, I think. Okay, right? So now it's 128, but okay. So we should go from like negative 150 to 150 here on y. Like we need a big range here, all right? And the y isn't really super important. E to the 7th? Okay, that's fine. So, but we just want to see it a little bit. Like you don't need to see all the y's, and you're right, you can plug it in. We're also multiplying it by a sign, which is going to make it smaller. Okay, but I'm going to go from like negative 150 to 150. And since I'm counting by that much, I might just count by 50s there. Now, again, what's most important is the x scale. And I'll show you a couple different things that this looks like. But if you graph it like that, then you see, let's graph my little blue thing. It goes up, comes down, goes back up again, right? Everybody got that? Now, again, this is f prime. So what this means is f is increasing initially, right? In this interval here, f is increasing. And then it's decreasing, and then it's increasing again, because f prime goes positive, negative, positive. All right, but let's say you didn't even change your y scale. Let's say you just did negative 10 to 10. All right, counting by 2's. If you graph it like that, which you don't need to, what happens is this graph is going to run off the screen, right? But you can still see the basic idea of what this graph looks like. Everybody got that? It's positive, then negative, then positive again, right? So again, the y is not super important as long as you can see if the graph's positive or negative. Okay. If the question asked, where does f have a local maximum, local max, then our answer is going to be right here. We got to find this value, but everybody see that? Answer is going to be right there. It's pi. And you're going to say because f prime is changing from positive to negative. That's how we talk about local max. It's pretty simple. You don't have to do a lot of work, okay? If the question was, where does f have a local minimum, do you all see where that's going to be? It's a little bit after 6. You guys see that right here? There's a local minimum right there because f prime is changing from negative to positive. That's how we talk about local maxes and local mins. But if the question, like this one, bless you, asks about absolute max or absolute mins, you got to follow this like step here that I'm going to show you. All right, the basic idea is you need to check the endpoints. You need to check the critical values of the function that they asked about. Okay, so right away, when I see what's the absolute maximum value of f on 0 to 7, I know I'm going to have to find f of 0, f of 7, and the y f of wherever this derivative equals 0, the critical values. Everybody got it? All right, so first thing we're going to do on our calculator is find those zeros. I'm going to graph it and find the zeros. On my paper, I'm going to write, hey, I know that I need to find out where f prime of x is 0. We're going to solve that equation. Anytime you solve an equation using your calculator, whether it's finding intersections or it's finding where things are 0, just write the equation that you're solving down on the paper. All right? in the free response section. This is important. So we're going to f prime of x equals 0. Then we're going to write x equals, and we're going to find these numbers, which is second, trace, and we want to find the 0. So we're going to hit 2. Now, if you can move the cursor back and forth and try to, like, all it wants to know is where should I look? Tell me where to look, between where and where. But you can see that first one is a little bit bigger than 3. Everybody see that? But it's definitely between like 1 and 4. So I'm going to tell the calculator to look between 1 and 4. I'm going to hit 1, enter, and then 4, enter. And it says guess. The guess doesn't really matter too much, but I'm going to guess 3, and it's going to find it. Now, everybody with me? It happens to be pi, which makes sense because our function is e to the x times sine of x. So that'll be 0 whenever sine is 0, which is at pi and 2 pi. Okay, but let's pretend this wasn't pi. Let's pretend it was some long decimal that we just didn't know what it was, which is some random number. Okay, we're going to want to use this number several times. So what we're going to do right now is store it in our calculator as a letter, so I don't have to keep typing it in. So right when you find an intersection or a 0, you know how your calculator stores the last answer it found, and you can just use that? The calculator has this x value stored. So I'm going to hit second quit. And on my home screen, I'm going to hit this button, STO. It's right above 1. That means store. So right now it says answer, stored as, and you can make it any letter you want. I always just use A and B. So you hit alpha, A, enter. And now anytime you hit alpha A, it's going to spit out pi. Cool. Again, it doesn't have to be pi, it just is in this case. Does that make sense? Go ahead.
How do you do the whole Y thing, like the one above it?
I'm going to show you that later, okay?
Okay.
You're going to use that right now. Cool?
All right.
Yeah, that was from another thing I was doing. Okay? Go ahead and find the second 0. There's 2 zeros on this thing. You can see it from the graph. Find the second one and store that as B. All right? Everybody play along. Okay? Good. Anybody not with me? On my paper, we're going to write, remember we wrote f prime of x equals 0? We're going to write the answers to that. And we're going to name them A and B, but we have to write the number out this whole way. Okay? So our first one, for right now we can, but a lot of times it's not going to be a nice number like that. It's going to be like a weird decimal that you don't know how to represent with a symbol. Does that make sense? So we're going to write it out as 3.14. 159, I don't know the rest of pi. 2654?
Yes.
And watch what I do. Equals A. So now anytime I want to write about that number on my paper, I can just write A instead of writing that number. Make sense? And then we also have an answer, x equals 6.283 something. 185,307. It's weird because that's my phone number. I know, right? Cool. You can, yeah. The first one's my social security number. It's really weird that popped up like that. Okay. So, everybody good so far? Find or ask to find absolute max or min. Automatically boils down to find the value of the function at the endpoints and at the critical values, which means first you got to find the critical values, which means you got to find where the derivative is 0 or undefined, and you're going to write that down, right? Where's f prime 0? Oh, right here. We found them both. Sound good? Only thing left for me to do right now is find the y value at these critical values and at the endpoints. Okay? But look, just looking at this stupid graph, does it make sense that f starts out increasing until 3.14? And then it decreases, and then it increases again, right? Does it also make sense that it's going to decrease Daniel, how you doing, buddy? What's happening on that phone? Big news? Breaking news? No? Okay. Just saying. You never know. It's going to decrease a whole lot more than it increased. Do you guys see that? Just because the negative area is a lot bigger. And it's going to increase some, but it's kind of hard to tell where the max might be. But this graph, the actual F has to go up, then down a whole lot, and then up some. Okay? All right. So we're going to find those values, and here's how we're going to do it. All right. This is kind of a lesson on some notation here as well. Do we agree that if I were to integrate from 0 to 7, we'll say, of f prime of x dx, what does that find? It's going to be a number. It doesn't find f. It finds something to do with f, but doesn't just find f. F is a function, right? What does this find about it? Very good. It's the change in f from 0 to 7. That's what this finds.
Oh, so if it's positive, then the value of 7 is the greatest, but if it's negative, then the value of pi is the greatest?
Not necessarily, because it could be bigger, so that's a good way to think about that, but it's not. It could be bigger positive somewhere else, you know what I mean? So we're just going to find all of them, okay? However, but the main point is this is not f of 7. You all understand that? It's how much f has changed. So what do I need to do to it to actually get f of 7? If I walked in this morning, there was $10 on the floor. I now have $10 more than I started, right? But if I said, how much money is in my pocket? You're like, I don't know. But if I had $5 when I came in and I found $10, how much money do I have? 15. That's super easy, right? So even though these symbols will make this a little complicated, it's the same basic concept. The integral is how much new stuff we got. What do we need to do to it to find out how much we have now?
Add how much we have.
Add how much we started with. Yeah, the integral is going to tell me how much it changed. I need to add how much I started with. And somewhere in the problem, they have to tell you how much you had at some point. In this particular case, I knew at 0 we had 125. That make sense? So if I do, and usually write it up front, 125 plus that, what is this finding? The integral finds a change. If I add 125 to it, what is this? What's this called? How can I denote this? This is f of, not f of x. That's what f is at 7.
Oh, okay.
If you take what it was at 0 and add how much it changed, by the time you get to 7, that's what it is at 7. Okay? This is a super big idea in calculus, especially for the AP test.
If I just put 0 to 4, then we'll be at 4.
So Justin brings up a good point. If I put a 4 here, if I want to f of 4, I need to integrate from 0 to 4. I want you all to stick with me because this seems simple. We're going to change the symbols up a little bit. It's going to look a little weird. It is simple, but it's weird looking. If I wanted to find f of a, I would integrate to a. Yes? So basically, I can find any value of f I want as long as I do 125 plus the integral from 0 to that value. True? So let's say I wanted f of x. What do I change? We integrate to x. Okay, so x is a problem now, yeah, so we got to deal with that. But does it make sense that this right now is the definition of f of x, even though it has an integral in it? Yes? A function can have an integral in it and still just represent a function. Here's one caveat, though. Ready? If you're going to use x to represent the value to which you are integrating, then you cannot use x again to represent the variable you are integrating. Does that make sense?
Oh, yeah.
It can't be both what we're integrating to and what we happen to be integrating. It's just easy fix. We just need to change the x in the integral to a different letter. And a lot of times what they're going to use is t. You can use anything you want, but most of the time you're going to see that. So now that represents the change in f from 0 to x. And even though you're seeing those t there, that t is there, that's like a placeholder variable. It's not doing anything. X is the real variable. Everybody okay? So if you write this on your paper like that, f of x equals this thing, then down here I can write, I need to know what's f of 0 I need to know what's f of a. I need to know what's f of b. And I need to know what's f of 7. And this is exactly what it's going to look like on the AP test when you write this out. You're not going to write this. So that's what's happening. Cool? And what's nice about this in math in general, if you define something to be a letter, like f of x is now defined to be this function, I don't have to keep writing it. F of a is just going to be this with an a plugged in. I'm going to do that, but I don't need to write that I'm doing that. Make sense? F of 0 was 125. We knew that. Do we expect f of a to be greater than or less than 125? Greater than, because the function increased, right? So the way we're going to do that is, remember in y1, we put e to the x sine x already. We're going to integrate that, and we're going to add 125 to it. Okay? So we can do 125 plus math 9, and you might have the older version of this where it says fn int right there, or you might have the newer version which looks like this. But I'm going to go from 0 to alpha a. Remember we stored, oh crap, I messed up. 0 to a. Everybody on board with that? Feel free to pause the video. Okay. Oh, it's real life. Okay. 0 to a. Because we're finding f of a, right? So to go from 0 to a, and all I need to do now is put the function I want to integrate. You can type it again if you want, but we put it into y1 already. So I'm just going to say integrate the function that's in y1. And the way you do that is you go to vars, which is right above tangent. That stands for variables. You want to go over to y variables. And what that gives you is the modes the calculator has. We have function, parametric, and polar. We will only ever be in function mode this year. So you always go into function mode, and you choose whichever function it is where you put what you're supposed to integrate. And we put it into y1. Enter. And then put an x back here. Everybody good? And all that's doing, remember that 125's there, the calculator is just finding the area under that graph, and that's how much it changed, well, f changed, and adding 125 to it. So f of a is 137.070. And it's not like a super big safety check, but it is larger than 125, which we expected. Okay? How do we expect f of b to compare to these numbers? Should be a lot less than 125, right? Because again, looking at the area, we had some increase, right? There's a positive area here. That's why f of a is bigger than 125, but this negative area is way bigger. So we expect to lose a lot more than we gain. So f of b should be below 125 here. Sometimes it's kind of hard to tell, but in this one you're going to see that's definitely going to happen. Now, something that's nice about the calculator, you can either copy and paste that, or if you have to keep typing in the same thing over and over again but changing one small thing, like right now I want to integrate to b instead of a. Right after you do it, if you hit second enter, it just drops the last thing that you typed in. And all I'm going to do is go back and change that a to a b, alpha b, and hit enter. Okay? And that gives me negative 142.246. Now, if we were thinking, we should have known that b could not have been an absolute minimum. I mean, absolute maximum, because it's definitely a minimum, right? The derivative change is negative positive there. But for these kinds of questions, just find the value of the function and all the critical values. That way you don't need to explain yourself. Okay? And then we got to find f of 7. So I'm going to go back to my calculator and hit second, enter, and go back and change that to a 7. Enter. And we get 72.3595. My 5s are looking especially sloppy today. Everyone all right with what just happened? So f starts at 125, it goes up to 137, it goes down to negative 142, and then back up to 72. Can you imagine that? 125, 137, negative something, 72.
What did you do on the calculator to get f of 7 again?
The same thing we did to find out a and b.
Oh, okay.
125 plus integral. Because remember, we have a definition of f of x. It's right here.
Mhm.
Just has an integral in it, but that's okay. All right? So let me show you this too. Another thing you can do, the calculator's kind of weird. If you don't want to keep typing that in y2, it is possible to do this. 125 plus math 9. And you put the integral in there. 0 to x. You guys with me here? I'm going to put y1 in there so I can type it in again, or I can actually go into here and say, hey, y1. Boom. Does that make sense? It's kind of like function inception, like functions and functions here. Cool. And then at the end, on paper, we had to use t, right? The calculator doesn't know all that crap. You just put another x there. So if you do that, now y2 is actually f of x. And you can graph it. It's going to take the calculator a long time to graph this because it has to integrate every point. But it'll do it. It's going to take it a very long time, so don't graph it. Matter of fact, if I were you and you were going to do this, I'd go to this equal sign and hit enter on it just so the calculator knows, oh, I went too far. Just so the calculator knows, hey, don't graph this. Make sense? Because every year a kid will be like, my calculator's taking forever to graph this thing. Because you're trying to graph the integral, and it's an intense amount of work. But anyway, if you do it like that, now rather than having to type that in again, if you go to vars, y2, and tell it a, you get exactly the same value that we got before. Does that make sense? So these are like little shortcuts on the calculator to do that. But anyway, recap, whole thing. Ask to find absolute max or absolute min on the AP test, which you will at least twice. Okay? It's going to be worth like 10% of your freaking AP grade. Yeah. Okay? No, don't do it. No, these are easy points to get because a lot of times you have a calculator for it. Okay? And we're going to do a free response question in a second, like a real one from the AP test. Number one, show you know you need to find the critical values. Show you know you need to solve for the derivative is 0, right? Write that down, solve it. And then all you need to do is find the values at the endpoints and those values, which we just did. We're basically done. We just need to write a sentence. I'm going to type it out because my handwriting is very sloppy. Ready? The absolute maximum of f of x on 0 to 7 is, sometimes they ask for the x value, sometimes they ask for the y value. You should give both. F of a, and you can write f of a. You don't have to type the number again. Once you write a equals on your paper, you can use a everywhere. Sound good? For that question, at least. Equals 137.070. Everybody good on that? That just answers the question. Then we're going to write one tiny little sentence explaining what we did. I checked the endpoints and you can write this two ways. We just checked the critical values of what function? Is it whether the critical values of f or the critical values of f prime?
F.
No, f. Yeah, I know, I got you. That's why I'm pointing this out, to make sure you guys don't make this mistake. It's easy. We found the what of f prime? We found the zeros of f prime. We found the critical values of f of x. Either one of them is correct to say here. Just don't say you found the critical values of f prime, because you didn't. Make sense? So I found the critical values of f of x. That's all you do to find absolute max and mins. Find the y value at the endpoints, find the y value at the critical values. Make sense?
So is it okay to say instead the zeros of f prime of x?
Yeah.
And then
Or
they'll know what you mean?
the zeros of f prime of x. Yep, that's fine. You don't say both of them, but yeah, either one of those is fine. Okay? All right. You guys feeling good? You look great. That's good. Okay. Let's stop this.